Hello viewers, welcome to EF. Today we are going to see advanced IT security. Topic of today's discussion is complexity theory. Today in this video we are going to see some example of undecidable problem like halting problem, totality problem and equivalence problem. We will also see some basic questions about how halting problem is can be proof that it is undecidable. So let's see. We know that halting problem is undecidable. Means there is no algorithm that can solve the halting problem. And so how halting problem can be defined? It can be defined as input of program P and an input W for the program P, where the output we will get yes if P terminates with W input, no otherwise. So we have another kind of problem called totality problem where we have input of program P, output is yes if P terminates with W input, no otherwise. There is another problem is called equivalence problem, and in this case we have input program P1 and P2, output is yes if P1 is equals to P2, no otherwise. Now we know that halting problem is undecidable. So how can you prove that halting problem is undecidable? What is the general idea behind the proof? That is the question. First, so very first, yes, halting problem is undecidable. The general idea is we will create a contradiction to prove that halting problem is undecidable. How? The question is how we can prove. Suppose we do have an algorithm that can solve the halting problem, and then we will apply the assumption in order to create a contradiction. And this is the general idea. By contradiction, we can prove that halting problem is undecidable. Question number 2, how we are going to create the contradiction? Basically, in 3 steps, we can prove that halting problem is undecidable. In the next question, I will say how, but the detailed proof will be in the next video where I will explain each steps how we can prove that halting problem is undecidable. So see, the first step we will assume that halting problem has an algorithm and that will have like simple input program P and W for that program P, and we have output yes or no. This is just a simple assumption that halting problem has an algorithm which has yes no output. Now in the second step we will create another program that is called absorb, and absorb will call input P inside of halting problem, and then itself it will call, and this program will just show the opposite result what the halting problem will show. Means it will just the negation of the result of the first step till to the second step it will not prove the contradiction. In the third step we will call absorb with itself, and this is the contradiction, and here we will see how it will prove the contradiction that halting problem is undecidable. I wish you will see the next video and where I would like to discuss each steps properly that how halting problem is undecidable. Thank you for watching this video. See you again.